In this lesson, we're talking about linear equations in two variables. A linear equation in two variables is any equation of the form ax plus by plus c equals 0. Now, please note that the x and the y can't have any squareds on it or any other exponent. So just x and just y. Linear equations in two variables are represented by straight lines. When graphed, the following are examples of linear equations. Notice on the first equation, y equals 1/3 x, we have x and y. Neither of them have any squareds or square roots or any exponents or anything like that. Notice this one's in y all by itself. Now this one has x and y both on the same side, but still no squares, so this is linear. Now the last two only have one variable x or y. These are also examples of linear equations because there is no squareds, okay? I know you're like, but wait, they don't have two variables, and the lesson's titled Linear Equations in Two Variables. There is a variable there. The coefficient is just 0. We'll talk about that in a bit. They're what we might call special case examples. Now we're going to spend a lot of time in this lesson using two forms of linear equations. The two forms are standard form ax plus by equals c. Notice it's x and y. A, b, and c are values where their coefficients a, b, and c are whole numbers or integers. Slope-intercept form is y equals mx plus b, and we'll be talking about that. This is a special form because y is all by itself, where in standard form the x and the y are on the same side. Both of these forms we will use to graph from. Now, linear equations in two variables have many solutions to them. In fact, they have an infinite amount of solutions. So, if we're to describe all the solutions, we need to represent the solutions on a graph. Like some of the other lessons we've already talked about, if there's an infinite amount of solutions, we can't actually list them all. There's just no way. The only way we can do that is to graph them, which is what we're going to do. So in this example, y equals 2x minus 3. Two of the infinite amount of solutions to this equation are listed below. I want to just make sure you can check to make sure that they're both solutions. Now, this is baby steps. I'm giving you 2 points, okay? Eventually, you're going to have to find your own points, but working up here, so this time I just give you both. This is the x-coordinate and y coordinate of a solution. Let's just make sure that it works. My equation y equals 2x minus 3. I'm going to plug in 0 for x, and I'm going to plug negative 3 in for y, and then I put a little question mark on top of side equals because I can't mathematically say that these two sides are equal until I prove it. So we have negative 3 on that side, 0 minus 3. You know what? That is true. So 0 comma negative 3 is a solution. So I'm going to go ahead and put that solution on my picture. Now let's try the next one. X comma y for 2 comma 1. Y is equal to 2x minus 3. So I'm going to substitute in for x a 2 and in for y a 1. And then I put a little question mark on top of the equals because I can't truly say that they're both equal until I verify it. So I have 4 minus 3 on the right hand side equals 1. Sure, that is true. So 2 comma 1 is also a solution. And as it turns out, that if you have two solutions for a straight line, if you connect them for a linear equation, we get all of the solutions. Every point on this line, in fact, a line is just made up of a whole bunch of points, right? So if you think of those as a whole bunch of points, just really, really, really dense, that creates a line, and that's just an infinite amount of solutions on your graph. How many points do you need at a minimum? 2 points to draw a linear equation, which is a straight line. Next, we'll talk about x and y-intercepts. Since linear equations in two variables are straight lines, and we need at least 2 points to draw a line. 2 easy points to find are the x and y-intercept. The x-intercept is the place on the Cartesian coordinate grid, that's just the xy plane, where the line crosses the x-axis, which is why we call it x-intercept, where the line intersects the x-axis. That's the x-intercept. The y-intercept is in the place in the Cartesian coordinate grid where the line crosses the y-axis. So just looking at these, can you identify the x and y intercepts just by looking at the picture? So this is my x-axis right here. So I'm looking along the x-axis to see where the blue intercepts it. And I can see that point is 1, 2, 3, 4, 5, 6, comma 0. On my y-axis, it intercepts right there at 1, 2, 3, 4, it looks like. Yep. Which is going to be called 0, comma, positive 4. Alright, let's do it again. This is my axis in red, my x-axis. Where does my blue line hit the x-axis? Well, in this case, it doesn't, so I'm going to write none. And the reason it doesn't is because my blue line is parallel to the x-axis, so it won't ever touch. Alright, so on my green, I'm going to highlight my y-axis. It looks like the blue line intercepts my y-axis at 0, comma 3. And on my last problem, on my x-axis here, the blue line intercepts my x-axis at 1, 2, negative 4. Negative 4, comma 0. My y-axis here, the blue line is never going to hit my y-axis, so I'm going to write none. There is no y-intercept for a vertical line. Notice that the x-intercepts are always written in the form some number, comma 0. This is kind of like a blank. Some number, comma 0. So to find the x-intercepts of any equation in two variables, all you need to do is substitute 0 in for the y. A lot of students get that confused. When they're thinking x-intercept, they want to plug 0 in for x, but it's not so. We need the x value, so 0 in for y, the opposite. Alright, look at these y-intercepts here. Now I know none doesn't really help, but the y-intercepts are always in the form 0, comma, some number. That's why they end up on the y-axis. So to find the y-intercepts of an equation in two variables, what you're going to do is substitute 0 in for x. Again, it's the opposite. If you're looking for the y-intercept, you plug in 0 for the x, because you want a value for y so that it could end up on the y-axis. So let's use this information to find the x and y-intercepts of the following equations and then graph the equations. So to find the x-intercept, we just said we're going to plug in 0 for y. So we have 4x plus 3 times 0 equals 12. Well, 3 times 0 is pretty easy. That's 0, it goes away. And then I divide both sides by 4 and get x is equal to 3. Now, in order to write my x-intercept, the x-coordinate is 3. What is the y-coordinate? Well, it's going to be 0, because we are the ones that plugged in y equals 0 to begin with. We knew that it was an x-intercept, we're going to plug in y equals 0. So for the y-intercept, we're going to plug in x is equal to 0. So we have 4 times 0 plus 3y equals 12. Well, that's just 0, so I have 3y equals 12. So my y-intercept is 4. But to write it correctly, the y equals 4 needs to go in the y-coordinate. Who goes for the x-coordinate? Well, 0. We're the one that plugged in 0 there. So for my x-intercepts, if I plot 3, 0, notice that does indeed end up on the x-axis, and 0, positive 4 does indeed end up on the y-axis. Then I can connect my line, and 2 points, the x-intercept and the y-intercept, was sufficient to draw a straight line. Now when they're in this form, in standard form, where the 4x plus 3y equals 12, where the x and y are on the same side, there might be an even easier way to do this. I call this usually the cover-up method. I don't really have a finger where I could cover this up, so I'm going to go ahead and scratch it out and erase it, but you would just use your finger. For the X-intercept, when I'm trying to find the X-intercept and I know y is equal to 0, instead of writing out all of this work, what I could do is put my finger on top of the y coordinate. Because I know 3 times 0 is always 0, so you wouldn't scratch this out. You would be putting your finger on top of the 3x. Then I'm just left with 4x equals 12. Could you solve this in your head and get 3 without writing a whole lot of work? I would hope so. So I'm going to go ahead and erase that because you never actually scribbled it out. You probably just put your finger over it. Now to find the y-intercept, we know x is 0. So put your finger over the 4x because 4 times x is 0. And we have positive 3y equals 12. Can you divide that in your head to get 4 without writing a whole lot of work? I would hope so. So take your finger off and now you have the two solutions. Now, are you welcome to write it all out? Yes, you can. On the next problem, I'm looking for the x-intercept. I know y is equal to 0. So, if I just want to use the cover-up method, I want you to put your finger over the y coordinate because negative 5 times y, which is 0, is 0. So if we just cover this up, then I have left 2x equals 15. Now, if you could solve that in your head by dividing both sides by 2, you can get x equals 15 halves, maybe without even writing anything down. So my x-intercept is going to be 15 halves comma 0. Now you didn't scribble that out, right? So I'm going to erase that. And in my y-intercept, we know that x is equal to 0. So my answer is going to be 0 comma something. So you would put your finger over the x term because 2 times 0 is 0, so you just put your finger over this, and then we have negative 5y equals 15. Divide that in your head and you can get negative 3. Now if you can't do that in your head, you're welcome to write it all out and that's fine, but I'm just trying to save some of you some time if you're able to do that. I'm going to erase this because you actually didn't scribble it, you just put your pencil over it. So 15 halves is actually 7.5 because 2 fits into 15 7 whole times with 1 left over. So 1, 2, 3, 4, 5, 6, 7.5 will be right about there. 0 comma negative 3 is going to be 1, 2, 3. Now if you are feeling like that is not good enough, 7.5 is not necessarily your favorite thing to graph, you can always find a third point. Now if someone asks you for the x-intercept, this is truly the x-intercept, 15 halves comma 0. You can't change that, but if you're like, I don't really want to graph a fraction, you could find a third point by just picking any value you want for either the x or the y. I'll go ahead and plug in, I guess 5 for the x. So I'm going to use the work down here. 2 times 5 minus 5y equals positive 15. 10 minus 5y equals 15 minus 10 on both sides. Negative 5y equals 5, and divide both sides and I'm getting negative 1. So if you wanted to, this is not required, but if you wanted to get another point that was whole, you could see that they are collinear and you wouldn't necessarily need to draw the 15 halves if that was a little uncomfortable for you to draw a fraction. Either way will work. So again, to find the x-intercept, this is in slope-intercept form because the y is already solved. No worries, I'm going to continue to solve the same way. This one's just a little bit difficult to use that cover-up method on because it's in the form, the slope-intercept form, so I'm just going to go ahead and write it out. So I have 0 equals 2x minus 6. Add 6 to both sides, and you have 2x equals 6. Divide both sides by 2, and I have x is equal to 3. To write that in the appropriate form, x is 3, so that's the first coordinate. We already knew y was 0, so that's the second coordinate. To get my y-intercept, I know that x is equal to 0. So I'm going to put 0 in for the x spot. Now this one is an okay one to solve with the cover-up method. If you cover up the x term, notice you can see y is equal to -6 pretty darn clearly there. It's just the other one took a little bit more effort, the red one, the X-intercept. So my Y-intercept is -6. So if I go ahead and plot the -6, 1, 2, 3, 4, 5, 6, and the 3 for the X-intercept, that is sufficient to draw a pretty good line. My last problem, now this one again is in standard form, so cover-up method might work really nicely here. So for the X-intercept, I know that y is equal to 0. And when I plug in 0 for the y, I could just cover up this whole term. And then I would just have 3x equals 0, and some of you could divide that in your head without doing any work, get 0, 0. For the y-intercept, we know that x is equal to 0. So when I plug 0 in for x, again, because it's in standard form, using the cover-up method, if you would just put your finger over the x coordinate, you get 5y equals 0, and a lot of you could just solve that in your head without even writing anything down, and get y equals 0. Again, this cover-up method only works if you're plugging in 0. So I have my x-intercept at 0, 0, so I'll plug that, graph that. But what happens here is when you plot these 2 points, they ended up being on the same point. We need 2 unique points in order to graph a line. So I am required, in order to graph this, to have another point. Any point will do. I'll go ahead and try 5 again. So I have 3 times 5 for x minus 5y equals 0, so that's 15 minus 5y. I cannot use the cover-up method because it is not equal to 0, so plugging in anything not 0 is not going to work. So I'm going to divide both sides by -5. I'm getting y is equal to +3. So when I plot this extra point that is not an x-intercept or a y-intercept, but I get another point, then I can draw a straight line.